Hey friends, welcome back to CodeOps Trek. In this second part of our Docker tutorial series, we will dive deep into essential Docker commands which are used to manage and operate Docker efficiently. So let's get started. In the last part, we explored how Docker works. We started with a bare metal server, a physical machine that provides raw computing power. Inside this server, we have essential hardware components like CPU, RAM, and storage. On top of this hardware, we install a Linux-based operating system like Ubuntu or CentOS. Then, we install the Docker engine on the OS, which is responsible for spinning up Docker containers, managing containerized applications, and help containers to communicate with the underlying OS kernel. Now, let's see how the Docker engine spins up or starts a container. To run a container, Docker needs to know which OS image will be used inside the container and what software and dependencies should be installed. All these details are stored in a template called a Docker image. So, Docker image includes files, binaries, and libraries, configurations needed to run an application, and a lightweight OS file system. So Docker engine starts a container basis of the Docker image. But where Docker engine get Docker image from? When we ask Docker engine to run a container, it searches for the Docker image locally, and if the image is not found, Docker pulls it from cloud-based registry which is called Docker Hub. Docker Hub is a cloud-based registry where developers can find and pull official Docker images, push their custom Docker images, and share and manage containerized applications. To push or pull images, you need a Docker Hub account. Now, let's dive into Docker commands and see this in action. Friends, right now, I am inside my newly created Azure virtual machine. To check its hostname, type hostname in the terminal, and we can see that it is set to Docker workspace. Next, to verify the operating system, type cat etc/os release, and it confirms that we are running Ubuntu 24.04. Since this is a fresh VM, Docker is not installed by default. To check this, type docker-v, and as expected, the command is not found. To install Docker, we need to go to the official Docker website. Open browser, and search for Install Docker on Ubuntu, and click the first link to install Docker engine on Ubuntu from the official Docker documentation. Scrolling down, we find the section titled Set up Docker's apt repository. Now, copy all the commands provided in this section. Now, go back to terminal. Before running these commands, switch to the root user by typing sudo su in the terminal. Now, paste the copied commands into the terminal and execute them. This will take some time as it downloads and sets up Docker's apt repository. Once this process is complete, again go back to the Docker documentation, copy the Docker package installation commands, and paste them into terminal. This step will download and install Docker on our system. This will also take some time to download Docker package and installing them, so we will wait till installation. After the installation is complete, verify whether Docker has been successfully installed by typing docker-v. As we can see, Docker version 28.02 is now installed on our system. That's it. Docker is now ready to use. So the very first command is docker-v, which is used to check the installed Docker version. Now, before moving to other commands, let's understand the Docker container lifecycle. A Docker container goes through several stages from creation to removal. The lifecycle begins when we pull Docker image, which serves as the blueprint for the container. The next stage is to create the container from this image. Once the container is created, it can be started, making it an active running instance. After starting, the container will be up and running in memory. Alternatively, we can directly start a container by running the Docker image, skipping the separate creation step. A running container can also be paused and later unpaused to temporarily halt and resume execution without stopping it completely. We can also stop a running container, which releases it from RAM but retains its state, allowing us to restart it later. If we restart the container, it will once again load into memory and continue running. Finally, if a container is no longer needed, we can delete a stopped container, permanently removing it from the system. So, that's how the Docker container lifecycle works. Based on this, there are primarily 11 important Docker commands that help us manage containers efficiently. First is docker-v, it is used to check the installed Docker version. Second is docker pull, it is used to download a Docker image from registry like Docker Hub. Third is docker create, it is used to create a new container from an image without starting it. Fourth is docker start, it is used to start previously created or stopped container. Fifth is docker run, it is used to create and start a container in a single step. Sixth is docker pause, it is used to pause a running container, suspending its processes. Seventh is docker unpause, it is used to resume a paused container. Eighth is docker stop, it is used to gracefully stop a running container. Ninth is docker restart, which is used to restart a container again. 10th is docker rm, it is used to remove a stopped container from the system. Finally, 11th is docker inspect, it is frequently used command to retrieve detailed information and logs of a container. Now, let's explore each command in detail with examples. So the first command is docker-v, which is used to check the installed Docker version. Now, let us see the next command, which is docker pull command. Open Docker Hub, and you'll find multiple Docker images available. Let's search for MySQL database and select the official MySQL image. Now, copy the docker pull command. Open the terminal and paste the command. Since we did not specify a tag, Docker will pull the latest MySQL image by default. This process will take some time depending on internet connectivity. Once the download is complete, we can verify the image using the next command, which is docker images. This command lists all the Docker images available locally. Here, we can see that the MySQL Docker image with the latest tag is now available in our system. We can also pull a specific MySQL Docker image by specifying its version tag. Let's pull MySQL 9.2.0 using the pull command specifying the version in tag. This ensures that Docker downloads the exact version rather than the latest one. Once the image is pulled, we can verify it using Docker images, and we can see that both MySQL images are available, one with the latest tag and another with the 9.2.0 tag. Now, let's pull another Docker image, which is Nginx, its popular web server. Copy the pull command and paste it into the terminal. Since we didn't specify a tag, Docker will pull the latest version of the Nginx image by default. Once the image is pulled, we can verify again using Docker images. We can see that the Nginx image has been successfully pulled and is available locally. That's how we can pull any Docker image. However, if the Docker image is in private repository, we need to authenticate using our Docker Hub credentials before pulling the image. Now, let's see the docker create command. A docker create command creates a Docker container from an image on the server. Every container should have a unique name. Inside the container, there will be service running. Let's create a container for Nginx, so we'll name it Nginx container. This container will run an Nginx server inside it on its default port number 80. But there's a problem. How will we access this server? Since the Nginx server is running inside the container on the server, we need a way to reach it. This is where port mapping comes in. We can map the container's port to any other port on the server or host machine. So, when someone accesses the server's port, the traffic will be redirected to the container, and the service inside will respond. So, with the help of the docker create command, we will create an Nginx container. Type docker create --name Nginx container 1 -p8080 port 80 Nginx. Here the container name will be Nginx container 1, the container port 80 will be mapped to the server port 8080 port. And the Docker image used will be Nginx. Please note that in port mapping, the first port represents the host port, and the second port represents the container port. So now, let's create the Nginx container. Type docker create --name nginx container 1 -p 8080:80 nginx. This command will create an nginx container named nginx container 1 and map port 80 of the container to port 8080 on the host. Now, the container is created, but how do we see the list of containers? Here comes another important command, which is docker ps-e. This command lists all containers, whether running, stopped, or just created. We can see our nginx container in the list, but its status is created and port mapping is not visible yet because we haven't started the container. Now, let's create another nginx container and name it nginx container 2, mapping its port to 8081. As soon as we execute the command, another Docker container is created. Now, we have two nginx containers, nginx container 1, which is mapped to port 8080, and nginx container 2, which is mapped to port 8081. To verify that both containers have been created successfully, we can run the command docker ps-e, which will list all containers, including the newly created nginx container 2, along with their statuses and port mappings. Now, let's see the next command, which is docker start. To start a container, we simply type docker start, followed by the container name or container ID. First, we will start the nginx container 1 by executing docker start nginx container 1. Our first nginx container is started. Now, let's start second nginx container. Type docker start nginx container 2. Our second nginx container is also started. Now, both nginx containers are running. To validate, we can execute docker ps-e, which lists all containers, whether they are running, created, or stopped. We can see that both nginx container 1 and nginx container 2 are in the up state, and their respective ports are bound to the host machine. However, docker ps-e lists all containers, including stopped ones, while there is another command, docker ps, which lists only running containers. Let's execute docker ps, and we can see that both running containers are displayed. Since both containers are up and running, let's access the first nginx container, which is available via our server's port 8080. Open browser, type public IP or localhost in case you are working on your local system, followed by :8080, and hit enter. Congratulations! Our nginx container is now being served in the browser through the first nginx container. Similarly, we can access the second container by opening another tab and hitting public_IP :8081. Once again, nginx is served on this port. This demonstrates how single service can run in multiple containers, and through port mapping, we can reach them individually. Now, let's see the next command, which is docker stop. The docker stop command is used to stop a running container, which leads to the service inside the container being stopped and becoming unavailable. To stop a container, simply type docker stop, followed by container name or container ID. For example, to stop our first nginx container, run docker stop nginx container 1. Our nginx container has been stopped successfully. To validate this, we can use the docker ps command, which lists only running containers. Since we stopped the first nginx container, running docker ps will show only nginx container 2, confirming that nginx container 1 is stopped. To see all containers, whether running or stopped, we can use docker ps-e. This command will list both nginx containers, and we will see that nginx container 1 has the status exited, while nginx container 2 is still running. We can validate this in the browser. Open the tab where the first nginx container was running and refresh the page. The nginx page is no longer available, and we see message stating, "This site can't be reached." This confirms that the first nginx container has stopped. Now, open the tab of the second nginx container and refresh it. The nginx page is still accessible because we only stopped the first container, not the second one. This demonstrates that stopping one container does not affect the other, even if they are running the same service. Now, let us stop the second container also. type docker stop nginx container 2 and run the command. Our second nginx container has also stopped. To validate this, run docker ps, and we can see that no running container is listed anymore. We can also run docker ps-ee, and both nginx containers will be listed with the status exited. Next, let's go to the browser and refresh the second nginx containers page. We will see that the nginx page is gone, displaying the message, "This site can't be reached." This confirms that both nginx containers have stopped, making the service unavailable. So far, we have explored multiple Docker commands. We pulled Docker images using the docker pull command, listed available images using Docker images, and created Docker containers using the docker create command. We also listed all containers using docker ps-ee, and checked running containers with docker ps. We started containers using the docker start command and learned how to perform port mapping to access services running inside containers. Additionally, we stopped Docker containers using the docker stop command and validated their status through docker ps and docker ps-e. Now, let's explore the next command, which is docker run. The syntax of docker run command is similar to docker create command, where we use docker run instead of docker create, and rest of the command is same. But there is an advantage with docker run command. Unlike docker create, which only creates a container, docker run performs the work of 3 commands in a single step. If the specified Docker image is not available locally, it first pulls the image, then creates a container from that image, and finally starts the container, making it run immediately. This makes Docker run a more convenient and efficient way to launch containers in one go. The docker run command has 2 modes of starting the container. First is detached mode and second is interactive mode. In detached mode, the container runs in the background while keeping the host terminal free. In interactive mode, Docker starts the container and provides direct access to its terminal or shell. But if we don't specify any mode while running a container using the docker run command, Docker will start the container in detached mode by default. Now, let's create and run another Docker container. We have a publicly available Docker image on Docker Hub, named as CodeOps tree preservation. This portal runs on port 80, inside the container, and its tag is v1.1. So, we will create and run a container, naming it tree preservation container 1, in the detached mode, and binding port 80 of the container to port 8080 of the host, using CodeOps tree preservation, version 1.1 image. Before starting the tree preservation container, let's check the available Docker images and containers on our system. First, we list all Docker images using the docker images command, which displays all locally available images. Since the tree preservation image is not present, it won't appear in the list. Next, we check for existing containers using the docker ps-e command, which lists all created, running, or stopped containers. Since we haven't started the tree preservation container yet, it won't be listed. Now, let's execute the docker run command to start the tree preservation container. Type docker run --name tree preservation container 1 in the detached mode -p 8080:80 CodeOps /tree preservation version 1.1. This command will first check if the tree preservation image is available locally. If the image is not found, Docker will automatically pull it from the Docker Hub registry. The time required to pull the image depends on the image size and network speed. Once the image is downloaded, Docker will create and run the container in detached mode, mapping port 8080 on the host to port 80 inside the container. We can validate this by listing the available Docker images using the docker images command. Here, we should see that the tree preservation image has been successfully downloaded. Similarly, we can verify the tree preservation container 1 by listing all containers using docker ps-e. This will confirm that the tree preservation container is created and running, with its status marked as up and its port mapped to 8080 on the host machine. Now, let us validate this on the browser. Open a new tab and type localhost:8080 in the address bar. Upon hitting enter, we should see a beautiful green-themed tree preservation website displayed. We can navigate through the site and verify that all its navigation links and functionalities are working smoothly, confirming that our tree preservation container is running successfully. Now, let's stop the container by typing docker stop, container name or container ID in the terminal. Once executed, our tree preservation container will be stopped successfully. We can validate this by listing all containers using docker ps-ae, where we will see that the tree preservation container's status is exited. To further confirm, open the browser tab where the tree preservation portal was running, refresh the page, and we will see message stating, "This site can't be reached," indicating that the container has been stopped. That's how we have seen how the docker run command pulls the Docker image, creates the container, and starts it. Now, let's move on to the next command, which is docker restart. The docker restart command is used to restart a stopped container. This command stops the container if it is running and then starts it again, making the service available once more. To restart the tree preservation container, type docker restart, followed by the container ID or container name. Once restarted, we can validate by listing all containers using docker ps-ae, where we will see that the tree preservation container has restarted and its status is up. To confirm, open the browser tab, refresh the page, and we can see that the tree preservation portal is up and running again. Now, let's explore the docker logs command. This command prints all logs of the application running inside the container. To execute this, simply type docker logs-f, followed by the container name or container ID. The -f flag allows us to follow the logs in real time, helping us monitor the container's activity as it runs. Now, let's check the logs of the tree preservation container. Type docker logs-f, followed by the container ID, and you will see the application logs being printed in real time. Now, refresh the browser, and you will notice that as soon as the page is refreshed, new logs are generated for the container. This is how we can troubleshoot any application issues by monitoring its logs inside the Docker container. Now, let us see the next command, which is docker inspect. This command provides detailed information about Docker container or image, including its configuration, networking details, mounted volumes, environment variables, and more. It helps in debugging and understanding the container's state. So, let us inspect the tree preservation container. Type docker inspect followed by the container ID or container name. This command prints all the details of the container. We can see the container ID, which matches the actual container ID. It shows when the container was created, its status, running, and the container process ID. We can also see the container name as Tree Preservation Container 1 and the port mapped with the host, which is 8080. The network attached to the container is overlay, and the image used to create the container, which is CodeOps tree preservation. There are hundreds of parameters available that provide deep insights into the container's state and configuration, which is very helpful for debugging and management. Now, let us see the next command, which is docker execute command. The docker execute command allows us to access the inside of a running container. To do this, we type docker executive in the interactive mode, container ID bash, which opens a terminal session inside the container. Once inside, we can check the hostname by running the hostname command, which returns the container ID as the hostname. We can also verify the OS file system of container by typing cat etc/os release, which displays the OS details. In this case, we can see that the container is running on Debian, which is a Linux-based distribution. We can list all the files inside the container using the ls command, which displays all directories and files within the container. To locate the HTML, JavaScript, and CSS files of the tree preservation portal, we navigate to the user, share, nginx, HTML directory. Inside this folder, we can see all the application files, including index.html, contact.html, and other necessary resources. This demonstrates how application files are stored and executed inside a running container. To exit the container, simply type exit and press enter. This command will bring us out of the container's terminal and back to the host machine. Now, let us see the last commands in the container lifecycle, which is docker rm and docker rmi. The docker rm command is used to remove a Docker container, while the docker rmi command is used to remove a Docker image. These commands help in cleaning up unused containers and images to free up system resources. Please note that, if a container exists in the system, we cannot remove its image. Before removing an image, we must first remove all containers associated with it. This ensures that no running or stopped containers depend on the image before deletion. We cannot directly remove a running container, so we first need to stop it. Alternatively, we can forcefully remove a running container. Now, let's remove the Nginx container too. Type docker rm, followed by the container name or ID, and execute. Once removed, we can verify by listing all containers and see that Nginx container 2 is no longer available. Next, let's remove the tree preservation container by typing docker rm, followed by the container ID and executing the command. After removal, we can verify again by listing all containers and confirming that the tree preservation container is no longer present. Similarly, we can remove a Docker image. Let's remove the MySQL of version 9.2.0 Docker image. Simply type docker rmi mysql 9.2.0 and hit enter. The MySQL Docker image is successfully removed, and we can verify by listing all Docker images to see that the specific MySQL image is no longer available. So, that's how we have explored the Docker container lifecycle and performed almost all the essential and extensively used Docker commands. This marks the completion of the second part of our Docker tutorial, where we covered all the important Docker commands. In the next part, we will dive into the Docker image lifecycle and learn how to create our own Docker image. So, stay tuned and subscribe to CodeOps Trek.